The video is now recording. I can see smoke, I can see particles moving.
Here we show aerosols generated during laparoscopic surgery. A light sheet generated by a galvanometer optical laser scanner is illuminating a 2D slice of the airspace above a patient undergoing laparoscopic cholecystectomy. Videography with an 8K ultra-high definition camera, the Canon EOS R5 with RF 35mm lens, is capable then of resolving particles moving into the operating room as scintillations. Here we see it at real-time speed. This shows the setup in the research operating theatre that we used to validate the methodology in a high-fidelity model with densely nebulized pneumoperitoneum. The absence of diffraction limitation enables droplets as small as 2 microns to be seen. Aerosol escapes from valveless trocars as well as from valved trocars with and without instrumentation. As a 2D light sheet sample of a 3D space, the particle concentrations are underestimated visually. A particle counter so can measure more accurately absolute particle quantity, as well as provide differential counts of relative particle sizes. Operating room positive pressure ventilation is tested at the time of theatre commissioning using smoke studies. On the left is shown smoke behaviour with room ventilation switched off. On the right, the effective dissipation of similar amounts of smoke with room ventilation set at our standard of 25 room air exchanges per hour. OR teams at work, however, impact airflow significantly. These simulation scenarios show that even with positive pressure room ventilation, crowding at the operative table by people and equipment causes local smoke stagnation in the operative airspace, and also entrainment due to body heat and movement. This explains the particle behaviour we are seeing during live operations. Here, again during laparoscopic cholecystectomy for patients with symptomatic gallstones, we see particles escaping from a valved 5mm trocar early in the case, prior to any operative dissection. Particles can be seen as scintillations due to the laser illumination even at this early stage. A particle counter can episodically sample the extracorporeal operative airspace without contaminating the surgical field. This provides a fuller understanding of the effluvium hazard. Here we can see gas and particle escape from a valved laparoscopic port during insertion and removal of an instrument. And here is a continual flue escaping from a valveless laparoscopic access port in a patient having surgery. This footage is taken during dissection of the gallbladder from the liver bed at a time when hook diathermy is being used. Particle counts in this operative phase are in the region of 1 million particles per cubic metre. Substantial amounts of particle escape is seen with specimen extraction. This methodology proves laparoscopy as an aerosol generating procedure that pollutes the operative airspace with particles, pollutants and perhaps pathogens despite positive pressure room ventilation. It provides too a means for assessing measures aimed at mitigating this occupational hazard.